What is up, Flutter devs? Today we're going to build a poor man's version of Flappy Bird. This is based on coding challenge number 31 from the coding train, I think. But if I remember correctly, I'm not sure that any graphics were involved with that. So we're going to take this up one notch, but it's still going to be a poor man's version compared to the real game. But let's jump into it and see how we're going to build Flappy Bird with Flutter processing. For those who aren't familiar with the game, here's a screenshot, I assume from the real game or maybe from some other version that somebody created. But the idea here is that you control this little bird, and every time you press a button, the bird lifts up a little bit, and then gravity pulls the bird down. Over time, these pipe things appear from the right, they move towards the left. If you hit a pipe, you lose. And then there's this background that also kind of slides, I guess from your perspective, slides this way as you move. What we're going to do is try to get the fundamentals of that same game. We're going to try to create some approximation of these pipes. We're going to have some approximation of a bird, and we're going to have a background image. Let's go see what we can do and how quickly we can do it. Now, I've already done a little bit of work here just to get some assets together because it's not really fun to watch me type a bunch of image stuff. Let me show you what we've got first of all. So I think, again, I can't quite remember the coding train coding challenge for this, but I don't think he used any bitmaps. We're going to use bitmaps. So I have a bitmap for the background. I have a bitmap for a pipe that appears at the top of the screen, a pipe that appears at the bottom. And then of course, because this is all Flutter based, I have a little dash image that we're going to use for the bird. It's not animated. It's not going to flap its wings or anything, but at least we have a dash. I've loaded all of those images here. I've also calculated the scale for the background. We want the background image to be exactly as tall as our sketch, which you can see right here. We have this vertically oriented sketch, this kind of portrait orientation. We want the background image to be exactly as tall as the canvas. And so I calculate the scale, and then I calculate the actual pixel width based on the scale. This is all just preparation for what we're actually going to build. I also set the canvas size, 400 pixels wide, 600 tall, and I have some kind of game constants in here. The background is going to move at some speed relative to the frame rate. It just so happens that I actually think moving 1 pixel per frame is worked out fine, but we could adjust that here. We could make the background move more slowly or more quickly. The pipe speed, so that's every single frame, how many pixels does a pipe move to the left, or from your perspective, that was right, to the left, to your left. And then what is the width in pixels of a pipe? And then we're going to represent the bird as a circle. Again, we have a bitmap, but in terms of hit testing, we're going to represent the bird as a circle. And what is that diameter? What's the size? It's 30 pixels. And then the bitmap of the bird, the dash image, how large should that image be compared to the hit test circle? And experimentally, I found that 175% the size is good for the bitmap. So these are all just visual properties as well as kind of game preferences that we can adjust and you can adjust as desired. But I didn't want to take the time to type all that with you here. Now within setup, we still need to, let me talk about the background for a second. When you're moving a background image across the screen, you always want 2 of them, because as one of them starts to move off the screen, you need to fill in the space to the right. You need a second image right behind, and then you keep flipping these images. So we're going to draw that background image twice, one after the other, and then we're going to keep switching them as they move off screen. We need to initialize those backdrop offsets here. We need to create some kind of bird object that we're actually controlling in the game. And then down in the draw method, we have a number of things to accomplish. We need to update the game state per loop. If the user is currently pressing the, let's say, space bar, we want to apply lift to the bird. We need to draw the background in the background. Then we draw the pipes. Then we draw the bird. Then we check to see if it's game over. And if it's game over, we draw a game over screen. Now, unlike the snake game that we did in the last video, we're not just going to fill the screen with red. Instead, we're just going to draw a red border and freeze the game right there. That's what we're going to do for game over. This is what we want to implement, so let's get to it. Let's see if we can get the background just looping first before we bring any of the actual game dynamics into this. And so this begins with, we need 2 offsets to track. So let's come up here. Let's see. Background stuff is up here. So we'll say late. And what do we want here? I think we just want a double offset, an X position, because the height is always exactly right. So let's see, backdrop 1 X offset and backdrop 2 X offset. We need to initialize those values. The first background is going to be left aligned here with our canvas and then start to move to the left. And the other backdrop will be exactly 1 backdrop distance away. So we will say backdrop 2 X offset is equal to the backdrop scaled width. All right, we're going to ignore the bird part for now. And let's create a method called DrawBackdrop. So we need to draw these 2 images, both at a Y value of 0 at the top and then at whatever the X offsets are. We have a processing API called image. For the image, we're going to say backdrop bitmap. That's the image that we're going to draw. And for the origin position, we're going to say offset 0, comma, backdrop 1 offset. And then the height, we're going to specify, because we want to scale this image, right? We want the height to be exactly that of the sketch. This is X offset. And then we're going to do the same thing for the second image. Now it's the same bitmap, but it's a different offset. Let's see, what is this complaining about? 2 double, 2 double. Okay, let's save that. All right, there's our image. And the image is wider than the canvas, so it goes some distance to the right. We want that backdrop to move. And I guess doing that up here and update the game loop is probably a reasonable place to put it. Let me check my notes here. Although maybe we just do draw and update backdrop, do it all in one place. Doesn't really matter, but probably nice to just see it all together. Okay, so we're going to say backdrop 1 X offset minus equals, meaning we're moving to the left. And we're going to say parallax speed multiple. Remember, that's 1.0. So every single frame, we're moving 1 pixel to the left. We could make that yeah, that's right. So, and we can make that larger to move faster, smaller to move slower. We're going to do that for the second image as well. And then the condition that we're interested in here is that if backdrop 1 X offset is less than negative backdrop scaled width. This condition means if our backdrop is so far off to the left that we can't see it anymore, it's completely off screen, then we're going to flip our 2 backdrops. We're going to say backdrop 1 X offset is equal to backdrop 2 x offset, and then backdrop 2 x offset is equal to backdrop 1 x offset plus the backdrop scaled width. This is how we keep the background moving over and over and over again. So let's see how that looks. Whoops, and let's see, why is it going with the Y? What did I do here? Oh, I did do that, didn't I? Offset 0, no, it should be that, comma 0, that, comma 0. Okay, now I don't know why that's moving in such a jerky fashion. I don't think I saw that before. It's possible that I have some performance issues on my machine due to the recording software. So maybe we're going to get stuck with some performance issues here. We'll see. But you can see it just keeps going. I'm not sure where the seam is. It might be right there. Not sure. But anyway, that's the backdrop figured out. What should we do next? How about dealing with the pipes? When it comes to the pipes and the bird, there are the collision boundaries, which we'll call those solids, the area that you can collide with. And then there's the bitmap, which isn't necessarily exactly a circle or exactly a rectangle. For now, we will draw the solids so that we can see what we're dealing with, but then we'll draw the bitmap and not worry about the solids. Let's come in here and let's say draw pipes. And we'll have to figure out how we're representing pipes and how to generate them and all that kind of stuff. Okay, and we're going to want, I think, objects for pipes. So let's define a class pipe. And we're going to have a left boundary. We're going to have a width. We're going to have we're going to have one pipe represent the entire vertical area of the screen. Note, technically there are two pipes and then there's a hole between them. We're going to consider this all one pipe, I think. And then there's the top opening and there's the bottom opening within the pipe. We're going to represent that with one object. And therefore we're going to have hole top and then we're going to have hole bottom. And then we're going to make these gettable. We are also going to have a getter for the right side, which is going to be left plus width. And then in the constructor, we're going to say pipe required double left, required double width, required double hole top, required double hole bottom. And we're going to assign those. So that is the fundamental structure of a pipe, but we know the pipes are going to move. So we want the ability to say move a distance. And then we're going to say left minus equals distance. And there's our definition of a pipe. Then the question becomes, well, two questions. One is, how do we generate pipes? And then two, how do we paint them? Let's create a method called createPipe. We know this needs to be semi-random. So let's create a random and then figure out what we're going to do with it. We need a top and a bottom to the pipe, a top and bottom to the hole in the middle of the pipe. So we're going to say hole top equals random.nextInt, and we're going to say height divided by 2 plus 50. Let me import random. Height is the height of our sketch. Height divided by 2 is therefore half the height, and we're going to get an integer so that we can get the next int. And that probably doesn't, I guess that could be next double, but it doesn't matter. So we're going halfway down the screen, and we're saying give us a value somewhere between the top of the screen and halfway down. But then we're adding 50. I'm trying to remember why we do that. That was an adjustment. Well, let's go with it. I don't remember what the adjustment was for. There was some reason for that. I think maybe that's to, I want to say that should be minus 50. The issue is that we don't want the top of the hole to intersect the bottom, and we want to make sure that we have enough distance in there. But whatever, we'll leave that as, actually, no, I know what that's for. That's so that the value is never 0. We always want the top of the hole to be at least 50 pixels from the top of the screen. We don't ever want it to actually be equal to the top of the screen, or even less than 50. We're saying 50 is our buffer. But now we're going to say hole height. So rather than randomly generate a top and a bottom, we're going to randomly generate a top, and then we're going to randomly generate a height for the hole. Say random next int. We're going to say 6 times bird size plus 3 times bird size. So here again, and maybe I name that something different. Bird solid size, I think is what we want. Solid meaning the actual circle that we hit test against. What this line means is that the minimum height that we will ever have for a hole is 3 times the height of a bird. This comes into game dynamics. If the hole is too small, the bird can't reasonably get through it, and so you're forcing users to lose. And then, of course, if it's too large, then there's no challenge. These are the kinds of things you would play with when you're balancing a game. But we're going to say at least 3 times the height of a bird, but up to 9 times the height of a bird. 6. So this number here could be, or this number here could be 0, or it could be as large as 6 bird heights. Well, that's the information that we need to create the pipe. We'll say return pipe. Left is going to be, we're going to start this all the way on the right side. And then we're going to say width is pipe width, which is a constant. Hole top is equal to hole top. And then hole bottom is going to be hole top plus hole height to double. Guess we'll call that there too. And then pipe width, let me go see what the name was for that. Pipe solid width. Again, I'm missing the word solid. That is how we generate a pipe. Now let's go look at actually drawing a pipe. We're going to take a configuration in here. We're going to say Boolean draw solids equals false. Solids, remember, are the hit test boundary, not the bitmap. We may want to debug what is the hit test boundary. If draw solids is true, then we're going to say we're going to have a fill color of blue, and we're going to say for final pipe in pipes. So we need a list of pipes that we are storing these in. For pipe in pipes, we are going to draw 2 rectangles, one for the top of the pipe, one for the bottom. We're going to say rect from left top, right bottom. We're going to say pipe.left. We're going to start at the top of the screen for the top pipe. Then we're going to say pipe.width, and then pipe.whole top. Believe that's correct. And then we're going to say rect from left top. This time we're going to, oh, so I said right bottom. So hold on. Left top, then the right is pipe.right, and then whole top. Okay. And then here pipe.left, and then pipe.whole bottom is going to be the top of this one, then pipe.right, and then the height of the whole sketch. Okay. So that should draw them, but still, how do we generate them? Oh, frozen here. So let's see, where do we want to generate these pipes? I guess we'll consider that part of the game loop. So first, we actually need to do two things. We need to remove pipes that are off screen and then possibly add pipes. So let's say pipes to remove. And we'll say for pipe in pipes, we're going to say pipe.move. We're going to say pipe speed. Then we're going to say if pipe.right is less than or equal to 0. And the bitmap might be a little bit wider than the pipe. So let's actually give it some extra space here. Let's just go -50. We'll let it go a little bit off screen. Then pipes to remove, add pipe. And then we're going to say pipes remove where is remove all something we can do? No, I don't know if there's an easier way to remove multiple items like this. You can let me know in the comments if there is. But we're going to say if that's a pipe to remove, then remove it. Now here's where we generate pipes. I'm going to add some comments to make this clear. Remove, let's see, update pipe positions, and remove any pipes off screen. And then we're going to generate new pipes. If frame count mod 100 is 0, so every 100 frames, we're going to add a new pipe. In an actual implementation of the game, you would want this to be more randomized and more about balancing the game dynamics. But for us, every 100 frames, we're going to create a pipe. Let's see what we got. Well, that's not looking good. So we do have pipes that are coming and going. Because I'm not passing true in for draw solids. There we go. And it's really too bad that we have this kind of janky, laggy behavior here. I'm not sure. It might be my recording software, but that's too bad. Anyway, those are the pipes. Let's actually get the bitmaps where they should be. So let's come back to draw pipes. And we should probably, I guess we should only loop through the pipes one time. So I probably want to move that conditional into the loop. Well, maybe not. Maybe it doesn't matter. So we take this same loop down here. Actually, we want to draw the pipes. We want to draw the bitmap first so that when we draw the solids, we can see it on top of the bitmap. We're going to end up drawing two images. We know that. One for the top, one for the bottom. The image is going to be up here as top pipe bitmap. And the origin is going to be pipe.left, then pipe.whole top minus, we need the height of the bitmap. So we'll come back and figure that out in a second. And then the width is going to be pipe.width, and the height is going to be, again, that height. So bitmap scale pipe.width divided by top pipe bitmap.width. This is the actual width of the bitmap in pixels. We want to shrink that down to be as wide as the pipe in pixels. That gives us a scale value. Then we're going to say top pipe bitmap height is equal to we're taking the max here because we don't ever want to inadvertently make it shorter than the pipe. Again, this is something that you just create assets to make sure that never happens. But in our case, we're just using the assets that I've been able to find. So we want to make sure that the height is never too small. We'd rather be too wide than too short. Okay, and then down here, we want, for the image, we want bottom pipe bitmap. The origin will be pipe.left and pipe.whole bottom. The width also is going to be pipe.width. And then the height is going to be the max of bottom pipe bitmap.height times bitmap scale. And that's a mistake I made above as well. Anyways, we're just calculating the height of these bitmaps so that they sit in the right place with roughly the right width. I guess I can just, for symmetry, I can take that right here and I can put that in line. And then let's see what that gives us. Oops, got some error here. What did I not do? So that's why we had the top bitmap height right there. Okay, let me undo what I just did. Let's say that's good. And we're not seeing them. Let's not draw solids and see what happens then. Okay, so there's the pipes. So those are the bitmaps. We're generating them as desired. They're appearing with different size holes. They're moving to the left. Eventually they're gotten rid of off screen. So I guess the next thing for us to do is maybe draw the bird. So let's say draw bird, draw solids. First, we're going to make that true, then we'll make it false. And I'll put that below the draw pipes method to follow the draw order. Not that it matters, just maybe a convenience when reading. So first, let's draw the solid bird. We will say if draw solids, then fill colors blue. Well, let's not make it be the same color as the pipes. Let's make it white. And then we're going to draw a circle, and the center is going to be bird.position, which we haven't created yet, and the diameter is going to be bird.size. And this brings us to the point where we need the concept of a bird. Let's create a class called bird. And I don't know if this is the greatest place to define this or not, but let's have a gravity force. And we're going to make that 0.3 based on experimentation. That's the force pulling the bird down. And we're going to have to apply that every frame. Now the bird is also going to need a size, which is a diameter essentially, so interpreted as a circle diameter. And we're going to want to be able to get size. Okay, and then we like to be able to get the left, top, right, and bottom very easily. So let's create getters for that. Let's say get left is position dx. We don't have position yet, but what we will. Actually, I guess let's create that first. Let's say we want an offset, which is the position, and then we want to be able to get the position. And then position dx plus size divided by 2, that's, minus size divided by 2, that's the left edge. And then there's the right, which is position dx plus size divided by 2. Then there's the top, which is position dy minus size divided by 2. Then there's the bottom, which is position dy plus size divided by 2. And those are for convenience to get the boundaries. Now, because we're applying gravity, we also need the concept of velocity. And then the bird itself will know how to update itself. But for the bird to update its behavior on a given frame, we need to know whether or not we should be applying lift. So when someone calls lift, we are going to say apply lift equals true. And that will be handled by our bird internally, which leads us to this update call. This is the game frame or the game loop for the bird itself. So if apply lift, we're going to say velocity minus equals, because on the screen minus is up, not down. So this is pushing up. We're going to add nothing in the x, but we're going to take gravity force and multiply it by 1.5. Now we could define our own any number right here that we want. But because gravity is always pulling down, and because the reason we want to lift is to push against gravity, it's probably better that our lift force be measured as a percentage or multiple of gravity, which is why we're doing that here. After we've applied the lift, we're going to set that flag back to false. Now, if we don't want to apply lift, then we're just going to apply gravity. And then we're going to update the position based on the velocity. And the velocity, therefore, can grow larger and larger, which leads to an acceleration. All right, now while we're here, we know that if the bird falls out of bounds, if it goes below the bottom or above the top of the screen, that's game over. So let's offer the ability to ask that question. Is in bounds. We need to know the height that we're dealing with. So we're going to return that the top is less than 0. So this is in bounds. So top is greater than or equal to 0, and bottom is less than or equal to height. So we will allow the bird to skirt the very top and bottom, but even 1 pixel above the top or below the bottom is going to be considered out of bounds. And now we need to actually take these values into a constructor. We'll have the bird constructor here. We will require a size. We will require an initial offset for position. And then you can pass an initial velocity if you want, but we're going to default to 0. Then we're going to say size is size, position is position, and velocity is velocity. Okay. And now we need the bird to actually exist as an instance. So we'll come up here and we will say late bird, bird. And right here where this to do is, we will say bird equals bird. And let me see in my notes what we want the initial values to be. Size is obviously bird size, bird solid size. But then position, we're just going to make it 100, 100. And let's see what happens here. Okay, so that's where we're going to begin. Now, we aren't running the game loop yet, so it's not falling. We can fix that pretty easily. Come right back here, and we'll turn this into a comment, and we'll say bird.update. Save that. And there it goes. Boom. Boom. We don't have any lift, though. What are we going to do about lift? Well, remember this to do. So here, to apply the lift, first we need to check to see if a key is pressed. Now, I left this method empty down here, but we don't need it. See, if the user presses a key many times per frame, we don't want to apply the lift many times. We only want to apply the lift one time per frame. And so what we're going to say, we're going to actually ask in the draw call, if key equals logical keyboard key dot space, logical keyboard key dot space, then we're going to apply lift. Let's see what that does. Not what I wanted. Oh, there we go. Ooh. Let's see. So it's applying it. Okay. So this key is remaining as the key even after I release. That's what I think is happening here. So what we actually want to say is key pressed and is it the space bar? Let's save that. Unfortunately, we're so laggy here that it's difficult for me to control this. But you can see now that we're going up and down, right? Up and down. Now, we don't have any collision testing here, so I can go right through a pipe, no big deal. But this is me hitting the space bar at some frequency, which maybe you can hear on the mic, maybe you can't, I don't know. But okay, that's that. Let's get rid of the update for a moment because I want us to paint the bitmap for the bird. And I don't want to have to keep it on the screen while we're doing that. So let's see here. So to draw the bird, once again, we're going to draw an image. The image is going to be bird bitmap. The origin is going to be, we'll calculate that in a moment, bird bitmap offset, and the width is going to be bird dot. Actually, we want the bitmap size. We want the bird bitmap size, and then the height is also going to be bird bitmap size because we have a square image. It's a transparent PNG. Now, what do we want that offset to be? Well, the bird bitmap offset is going to be bird.position minus, let's see, the bird bitmap size, bird bitmap size divided by 2. So the bird.position is the center of it. And, well, you might think we could say bird.top, bird.left, but the bitmap size is not the same as the solid size. So we actually have to calculate this ourselves. So we take the position and then we take 1/2 the width and 1/2 the height of the bitmap. Let's see what that gives us. All right, so you can kind of see the tail and the beak. So what we're going to do now is remove the solid. We're going to say, don't draw the solid. Hey, and there's our little dash. Clearly not an image made for this resolution, but it's close enough. And now we can bring back bird.update. And now we've got this funny looking flying dash. And now we have to, one, we have to check the bounds, and two, we have to check for collisions. Let's come back here. Check for game over. We'll put the draw calls all together and check for game over. So that's a behavior that we want here. We'll put that down here. Check for game over. So if the bird is not in bounds, and that's based on the height of the sketch, then is game over is true. We need to create a variable for is game over. Okay, and then we need to say for final pipe in pipes, if bird, we need to implement this, did hit pipe, pass in the pipe, is game over is true, and we can return. Those are the two conditions that will cause the game to end. So now we need to go into bird and we need to implement that did hit pipe. Boolean did hit pipe, take in a pipe. If right is less than pipe.left or left is greater than pipe.right, return false. So if the right side of the bird, if the bird is to the left of the pipe or completely to the right of the pipe, we can't possibly be intersecting the pipe. Return false. If the top of the bird is less than whole top or bottom of the bird is greater than pipe dot whole bottom, then we have hit the pipe. So if we bypass the first if statement, then we are either in the hole or we are hitting a pipe. So if we get to this statement and we're not in the hole, then we're definitely hitting the pipe. Otherwise, we're in the hole. Check for game over. Now, finally, I mean, that will run the check, but we also need to say draw game over. And for that, we will say we want a red border around the screen. So no fill, color is colors.red, stroke weight, we're going to say 5. Then we're going to say draw rect from left top width height from the top left to the width of the sketch and the height of the sketch. We're also going to stop looping. We don't need to draw any more after that happens. So we'll come back up to the draw method. We check for game over, and then we're going to say if is game over, draw game over. Yeah, that's what I called it. Okay. Let's see. Falling down, there's game over. Let's try going up, game over. Let's try hitting a pipe, game over. Let's try not hitting a pipe. There, we're going through the hole. Okay, so we're able to get through a lot of these. Let's hit one again. Boom, game over. Okay, so that's what it took. We now have a poor man's version of Flappy Bird, and you can go add all of the complexity to this that you want. So from here, I think I'm not sure what coding challenges make sense to do next, but I'll probably look for some more. Again, we're stress testing this thing. We're trying to see what all can we create, where are the holes, what's missing. I'm going to continue down that road for a little while. Once I've done enough variety, then I'm going to consider this thing, let's say in a beta state. I'll cut a new release for pub dev. And then, like I said in my quarterly review, Q3 review, I'm going to kind of hand this over to all of you to share it or not. It's up to you at that point. But I will have gotten you to a semi-stable state where you can create a bunch of interesting things. So with that, I will see you in the next video.